on an incredible generational run of finding general solutions to these second order differential equations. So I'm going to continue it. When solving a linear coefficient differential equation, we assume the solution in the form of yx equals e to the rx. Let's differentiate that once, and that's going to be re to the rx. And let's differentiate that again for the absolute lols, and that's going to be r squared e to the rx. Let's now take each of these, substitute them in here, and make it equal to 0, because that we're only going to be looking at the homogeneous part first. So you're going to get r squared e to the rx plus 5 rerx plus 6 e to the rx, and make that equal to 0. Let's substitute out e to the rx. So you're going to get r squared equal plus 5r plus 6, which equals 0. Divide both sides by e to the rx. That vanishes. We can now easily factorize this, and that's going to be r2, r plus 2, r plus 3 equals 0. So therefore, r equals minus 2 or minus 3. We should remember that there is a little bit of the complementary solution, or the homogeneous solution, is xh equals c1 e to the, and then you put the number in, minus 2t plus c2 e to the minus 3t. We've now found the homogeneous part, which is the left-hand side. So let's find the particular solution. That's when we deal with the right-hand sides. We've got some cos here, some sine, some trig, bit of a goof, bit of a gaff. So we're going to have this particular solution, which is a cos t plus b sine t. If we differentiate this once, you're going to now get minus a sine t plus b cos t, and let's differentiate it again for the absolute superlols, and that's going to be minus a cos t minus b sine t. We're now going to take all of this banter and shove it in here. So you're going to get this goes here, this goes here, this goes here, just to be clear. So a cos t minus b sine t plus 5 minus a sine t plus b cos t plus 6 cos t plus b sine t, and we're going to make it equal to 2 cos t minus sine t. Nice and simple. Now we clean up. Let's have some fun doing that. And it's going to be, if I group everything together, subtract or add anything that can be done. If I quickly do this in my head, blah, 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 there we go. We've got 5a plus 5b cos t in brackets minus 5a plus 5b sine t, which is equal to, I'm just going to put a double line here, obviously the right-hand side. Now we can equate coefficients. We know that the cos t's on the left-hand side are going to be, I'm going to put cos t here, 5a plus 5b, and on the right-hand side we have a 2 next to the cos t. So that's just going to be there. So we can then rearrange that, and we would know that a plus b would be 2/5. So now let's look at the sine t's. So here we have minus 5a plus 5b, minus 5a plus 5b, and on the right hand side we just have a minus 1 next to the sine t. So if we rearrange that, you're going to get minus a plus b equals minus 1/5. This is 1, this is 2. We can now put 2 into 1. So let's put 2, substitute into 1. So you're going to get a plus a minus 1/5 equals 2/5. So that means you're going to have 2a equals 3/5. So therefore a would equal 3/10. We can now take this value of 3/10 and shove it into either 1 or 2. I'm going to put it in 1. I didn't mean that. I'm going to put 3/10 into this one equation. Okay. So 310 into 1. So it's going to be 3/10 plus b, which equals 2 over 5. So therefore, b is going to be 1/10. We've got this somewhere here. There we go. So xp is going to be a, which is 3/10 cos t, plus b, which is 1/10 sine t. But remember, you're probably going to need to do this, that x equals the homogeneous part plus the particular solution. So let's bring it all together. We have here x equals c1 e to the minus 2t plus c2 e to the minus 3t. Add the particular solution, 310. A lot of people tend to just leave this. They've done all this hard work and then they don't add in this last line, and they can lose a mark potentially for doing so. And there we go. We found the general solution.